The production of electricity. In this lesson, we're going to be covering non-renewable energy, fossil fuels, nuclear fission, renewable energy, solar electricity production, future solar technology, wind turbines and farms, hydroelectric power, geothermal, and nuclear fusion. Renewable versus non-renewable. Renewable resources renew themselves over the course of a normal human lifespan, and usually a lot faster than that. When you think of renewable, you think more in terms of wind and solar, and those things happen constantly. Non-renewable resources are not able to replenish themselves within a human lifespan, and again, they're usually much more exaggerated than that. Things like nuclear fossil fuels take millions and billions of years to replenish themselves. Fossil fuels are a non-renewable resource. Examples include oil, gas, and coal. Energy released from the combustion of these materials is relatively cheap, but the world supply is decreasing. It took us billions of years to build it up, and we've used a good portion of it in the last 100 years. And the usage of these materials has led to pollution problems and climate change. Fossil fuels. So how does a fossil fuel energy production work? Well, what you have, and this is pretty consistent for any kind of energy production, is you're going to start over here with the cold water. So you're going to have cold water right there. And what happens is that this cold water is going to be pumped into this heating chamber. Now, this heating chamber for fossil fuels is where the fossil fuels are going to be burned. So if you think about fossil fuels down here on fire, when they catch on fire, they're going to give off a lot of heat. And that heat is going to turn this cold water eventually into high pressure steam. When the water molecules start moving faster because they gain more energy, they become steam. The steam is going to carry a lot of pressure. When that pressure travels down the shaft, it hits the turbine. When it hits the turbine, it causes the turbine to spin. As the turbine spins, it causes this shaft to rotate as well. When the shaft rotates, it causes the generator to produce electricity. That electricity is then sent via power lines to your house. Fossil fuels. Coal, oil, and gas are called fossil fuels because they have been formed from the organic remains of prehistoric plants and animals. However, most fossil fuels we use today were formed from plant remains well before the dinosaurs came into existence. Nuclear fission is the means of nuclear reaction we use to produce energy. So what happens is that we get a neutron captured by the nucleus of our U-235 atom right there. Once the neutron's been absorbed, it briefly turns that uranium into a uranium-236, which is highly unstable. That U-236 then breaks apart into Ba-141 and Kr-92, so two different atoms, plus a few other neutrons. These neutrons then go on to produce more reactions the same way that this neutron did up here. In addition to the atoms that are created, there's a whole lot of energy that is produced. And that energy can then be harnessed to create electricity. Now, what are the negative effects of nuclear fission? Well, we get a significant radioactive waste problem. And these waste materials can be deadly for centuries. And there's really nowhere to put them. Essentially, what we need to do is we need to put them in an area where they can be contained until they're no longer dangerous, which, as I said, is a very long time. Now, how does this relate to energy production? Well, the reactor uses uranium as fuel. When the neutrons smash into the nucleus of the uranium atom, it splits roughly in half and releases the energy in the form of heat. This heat created from the nuclear fusion heats our water, just like we did with the fossil fuels, and that makes steam. The steam, just like the fossil fuels, turns the turbines, which turn the generators, which produce electricity. And here's an example of what it looks like once again. So here's our heat chamber. So instead of fossil fuels being used, we're going to have a nuclear reaction, our fission reaction. So this nuclear reaction produces a great deal of heat, so much heat that it changes this cold water into steam, which again gets pumped down to the turbines, causing them to spin, causing the crankshaft to spin, causing our generator to produce electricity. Renewable energy. Renewable energy comes from resources that renew themselves constantly. This happens quickly and is always available. Some countries, such as Sweden, completely rely on renewable energy for their electricity needs. The most common renewable energy sources include things like wind, water, solar, and geothermal, among others. Solar electricity production. Every minute, enough sunlight reaches the Earth to power everything we do for an entire year. It's pretty incredible. Currently, solar energy only produces about 11% of the world's energy production. However, the possibilities are endless, assuming we can come up with a better means of collecting that energy. How solar energy production works. Our most efficient use of solar energy is done in space. There we receive 100% of the sun's energy since there's nothing between us and it. You think about the International Space Station, there's nothing between it and the sun, so all the energy can be directed to those solar panels. On Earth, the sun needs to pass through the atmosphere, the clouds, before it reaches us, and a lot of the energy is lost. Solar energy production allows homes and office buildings to use less energy from the electrical grid. By using more solar and less fossil fuels, we can reduce the release of harmful greenhouse gases and help fight climate change. And there's some pretty neat solar technology in the pipeline. The trouble with solar tech right now is that it's expensive and it doesn't look very nice. So if you take a look at this house down here, it's great that they have solar panels put up on their house, but they're not the nicest to look at all the time. But there are some recent innovations that could change that. One example is our transparent solar panels, which can be attached to windows in other areas. Think about all those buildings downtown collecting energy through their transparent solar panels. Other things like Solar Roof by Tesla looks like a regular roof, but each shingle is a solar panel that provides electricity for the home. So it's a substantial energy production method that looks good. It looks like a regular roof. Wind turbines. Wind turbines can power between 1,500 and 3,000 homes each. They work by harnessing the power of the wind to rotate a turbine, just like the nuclear and fossil fuels examples that we talked about before. However, in this case, we're not creating steam to turn the turbines, we're just using the wind to turn the turbines. So by turning the turbines, we can then rotate the shaft inside the generator to convert the mechanical energy from the wind into electrical energy. Wind farms. A wind farm or wind park is a group of wind turbines in a certain location. They can have upwards of several hundred individual wind turbines or as few as a few dozen. Now, the Gansu wind farm in China can produce 6,000 megawatts of power, and the largest offshore wind farm in California can produce 1,020 megawatts, so pretty substantial. However, in comparison, the largest nuclear power plant in Japan has a capacity of 8,000 megawatts, and the largest fossil fuel burning plant produces 22,500 megawatts and is located in China. You can see that these non-renewable sources do provide a real cheap, easy means of producing electricity, which is very appealing at times. However, we also need to keep in mind that these energy sources are not sustainable and they do a lot of harm to the environment. So the controversy of wind farms. So some people complain that the wind turbines kill migrating birds and cause noise pollution. Wind farms take up an enormous amount of space with hundreds of square miles needed. However, you can also say that most of the land that is used for these wind farms is also available for other things because the wind turbines themselves only take about 1% of the land. So you can put a wind farm on a farm and still have most of the land, 99% of that land, available to do the actual farming. Hydroelectric power. The water cycle causes evaporation and rain to fall in high geographic areas. The water then flows back to sea level. In electrical power stations, we're able to harness the motion of the water flowing down to sea level and convert that energy into electrical energy. Examples of that include dams. This is the Hoover Dam here. You can see that we get a large amount of water built up top, and as it flows down here, we can convert that, what's called energy of position up here, so that's position energy, into energy of motion as it flows down. And then we can harness that energy of motion to produce electricity. So how does this work? Well, a dam is built to trap water, usually in a valley where there's an existing lake. Water is allowed to flow through tunnels in the dam to turn turbines and thus drive the generator, just like we saw with the wind turbines, just like we saw with the nuclear and fossil fuel. All we're trying to do is create that motion of the turbine. And as a very simple example, you can see here in this picture, when the water flows down, it hits these blades and causes them to turn. As they turn, they're able to power this generator to produce electricity. Now, here are two pictures that I took from Hoover Dam itself. So there's Hoover Dam, and then I took these pictures inside. So these are the actual tubes where the water flows down. So it's going to flow this way as it exits the dam that way. And as it does, it's going to turn those turbines, which are going to cause these generators right here to produce electricity. And here's another picture of what it looks like. So we get that buildup of water here on the right-hand side, and we let that water flow down through what's called the penstock. So if you look back at this picture, these things right here, these are the penstocks. So water is able to flow down through these, and as they pass by the turbine, it causes the turbine to turn. As it turns, it causes the shaft here to turn, which causes the generator to produce electricity. The water is then able to flow out here, and then eventually the sun will provide energy to the water, causing it to come back up here and land above the dam in the reservoir again. Geothermal. Thermal or heat energy from beneath the Earth's crust is harnessed to produce electricity. Water is pumped into the Earth and converted into steam underground, just like we converted the other water to steam using the heat from the fossil fuel reaction and from the nuclear reaction. This steam comes up and is used to drive the turbines, which drive the electric generator. So same idea, except we're getting steam by pumping water into the ground where it's already hot. That ground heats up the water, creates steam, the steam comes up and is able to turn the turbines, which allow the generator to produce electricity. Nuclear fusion. Joining nuclei from small particles to form one large nucleus and a neutron. Nuclear fusion is a process that occurs within our sun as hydrogen nuclei combine to form helium, and this would be our ultimate source for energy production. If nuclear fusion could be harnessed, it would be able to solve all our energy needs because it just produces so much energy. So you can see what happens here. We're going to get these two guys. So these two are isotopes of hydrogen. So we get this guy and this guy coming together. They create a reaction, release helium, a neutron, and a ton of energy. Now, how much energy? Substantially more than a fission reaction. So if we could harness nuclear fusion, we'd be able to solve all our energy problems in a clean and renewable way. And that concludes the lesson on producing electricity.